Hello, my dear friends. Welcome to another video on exponential functions. In today's lesson, I'm going to look at some exponential equations, how to solve them. And the second part is also going to be on practical applications of exponential functions. I bet you didn't know how useful exponential functions could be. But at the end of this lesson, you see how vital it is in the world of biology. Now, before we start, don't forget to like and subscribe. And don't forget to share the link with your friends. Let's start off with question 5. Now, question 5, I'm sure you're wondering whether it's a question on exponential function. It is the C part. The C is on exponential functions. So 2023. Okay. So now they say that we should show that this is a factor. If x minus 1 is a factor, that means x is equal to what? 1. If I place it in this function, I'll get what? 0. Okay. I can say this is p of x. Let p of x be the function, eh? So if you put in a value into your function and it's equal to 0, then x that factor, that expression is a factor. Okay, so hence x minus 1 is a factor of the polynomial p of x. So you get 1 point if you're able to do this. Hence writes this as a product of linear factors. Okay, so we can use the long division method. I know that that's what most of you like, so let me use that one. We are dividing by x minus 1. X cubed divided by x will give you x squared. Okay, then you multiply by the brackets, you get x cubed minus x squared. So now let's subtract. It's negative x squared. Negative x squared divided by x is negative x. So if you expand, you get negative x squared plus x. Now let's subtract again. This should give you negative 20x. Then you drag this guy down here, you get 20. Negative 20x divided by x will give you negative 20. So if you expand, you get this. Okay, so you should have a little knowledge on cubic functions. So having gotten this, so you can say p of x is equal to x squared minus x minus 20. And this can be written as, if you solve this quadratic, you're going to get x plus 4, x minus 5. Okay, I solve this quadratic and I'll get this. So that's it. You have broken it down into linear factors, products of linear factors. Now, if you look at this expression carefully, you can see something. You can see that e, this can be written as e to the power y in one bracket, e to the power y squared in another bracket, minus 19 e to the power y plus 20. So what they have done is that they have let e to the power y be what, x. So this is just like what the polynomial function that they gave you, the original polynomial function. So have you seen? So if that's the case, if you want to solve this, you have already expanded it here. So let me just do some copy and paste. However, your x is now, your x is now e to the power y, e to the power y, e to the power y. Everything is equal to 0. Okay, so when you have the first factor, e to the power y minus 1 is equal to 0. Now this is the same as this. You can find lane of both sides. So you get y is equal to lane 1, and lane 1 is 0. Okay, remember that I told that logarithm of 1 to any base at all is what? 0. So whether it's base e or anything, it's still 0. So you should be able to remember that. Now, what about this? When you have e to the power y plus 4 is equal to 0. Let's see whether this will work. So here your argument is negative, so you can't solve this one, eh? So no real world solution. In fact, if I'm the one solving this, I will not even start. I will not even solve this at all, because you don't get any mark for it. It's just a waste of time. So you can, if you can just see it from scratch, please don't tackle it. So I find I find this lane of both sides. So I get my y to be lane 5. Okay. They say find the exact solution. So if I get lane, I shouldn't break it down. Leave it like that. Don't break it down into decimals. So that will fetch you 2 points. Okay, let's look at question number 7. Now this can be written as 6 times 3 to the power this. Okay, have you seen? So at this point I want to multiply this by this. Okay, and divide both sides by 3y. So that should give me, it's like I'm doing a little bit exchange. So I'll bring this one here. I'm dividing both sides by 3 to the power y and multiplying both sides by 6. Oh, by 5. This one, the 5. So this should give me, is equal to 30. Okay, and at this point I want to find logarithm to the base 5 or both sides. Log to the base 5 of 30. Okay, now this is the same as, let me squeeze this one to the left so that I have more space. Okay, now this is the same as, now your arguments are dividing, so you subtract the logarithm to the base 5. Okay, so this is the same as 2y, because the power from the power rule, the the power will jump down and become the coefficient. So this one can be written as this. Okay, so at this stage everything becomes simple. What am I trying to do? I'm trying to make y the subjects. So I can see they have y in common, so I factor y. So I divide both sides by the expression here. 2 minus log 3 to the base 5. So now let's punch this and correct our answer to 3 decimal places. Okay, 3 decimal places. I'll get 1.0 1.604. So that will be my answer. Okay, let's see the B. The B is very easy. I think I saw a similar one in the previous question. So this can be written as 2e to the power x 2x, okay, minus this plus. All right. Then here I can say let e to the power 2x be y. So I'm going to have y minus 4 plus 3 over y. So what do you do at this point? You just express as a quadratic. How do you do that? You can multiply throughout by y. So this will give you y squared minus 4y plus 3 is equal to 0. Y times y will give you y squared. 3 times 1 will give you 3. Cross multiply. 3y cross, you get y. What can I do to these two terms to get the middle term here? When I subtract them, I'll get negative 4. So I'll bring the same operation here, negative, negative. So my factors are y minus 3 into one bracket, multiplying y minus 1 in another bracket. So y is equal to 3 or y is equal to 1. Okay, so now let's conclude. Don't forget that you said that e to the power 2x is equal to y. So when y is 3, let's see what you get. Okay, and when y is 1, You find length of both sides. Lane 1 is 0. So if I divide both sides by 2, I'll still get 0. So x is 0 or x is equal to half lane 3. I hope you know that this one can be written as lane 3 to the power half, which is the same as square root of lane square root of 3. Okay, so they can tell you to leave your answer like this. So yes. All right. Okay, let's take this question. This is a simultaneous equation question. All right. So if I'm solving this question, I'll let the variables represent a letter. So this is the same as a plus b is equal to 5. And this one can be written as 2a minus 3b is equal to 8. All right, so this is equation 1. This is equation 2. I can make from equation 1, I can make a the subject. A is equal to 5 minus b. Let me call this one equation 3. So I'm going to put 3 equation 3 into equation 2. Okay, so that will give me, so I'm getting b to be 2 on 5. So if b is equal to 2 on 5, it will be what? From here, 5 minus 2 on 5. Um, so this is the same as, okay, this 5. 25 minus 2, 23 on 5. So a is 23 on 5. Okay, but don't forget, you're not done. You said that e to the power x is the same as what? A. So e to the power x, your a is what? 23 on 5. So what do you do here? You find length of both sides. So I'm going to get x to be length 23 on 5. What if I have e to the power y is equal to b? B, don't forget that I said that one here. Okay, and so b is going to be 2 on 5. So I take length of both sides. Mm, So I'm going to get this as my answer. Okay, now I'm going to take this one as my last sub question under exponential equations. Then I'll start with the practicals. Okay, so now here, this question, you can choose to, there are so many ways of doing it. You can take length of both sides. So I'm going to get, so the power will jump down. So I'm going to get this ln 5 plus ln e to the power this, right? And this is the same as the power will come down here. So it's the same as 5t minus 3. So I try to make t the subject. So when the 5 comes here, I'm going to get negative 3t. Uh, Negative 1 comes here, becomes plus 1. So plus 1 minus 3, that's negative 2 plus ln 5. So if I divide both sides by negative 3, I'll get this. So should be my answer. And this is going for 4 points. This actually my answer in something. Okay, they didn't say anything. So you can leave your answer like this. You can choose to expand and you get this as your answer. All right. This one is correct. All right. So let's delve into something else. The practical. So this is not my material, but I got it online and I think they have some of the practical questions. Let's start with this. The first one. So look at a question like this. You see the population P. So P is the population of a certain bacterium T days after the start of an experiment is modeled by this. So in mathematics, we have something we call modeling, where mathematicians find a formula for, let's say, the growth of a bacteria, the rate at which the bacteria grows. So you can model an expression for it. Okay, it's a whole course in mathematics in the university. And some people do this as their masters. All right. So here we are just going to just apply the exponential equations we learned to solve this question. Now they are asking the first one that you should state what figure 800 represent in this experiment. Okay. Now uh, I know many students will say that this is the rate of the experiment, the 800. But you can't be quick to conclude like that. Now, what you need to know is that at the initial time or at the beginning of the experiment, your time is what? Zero, because you are now starting afresh. So time is what? Zero. So now let's put that value into this and see what you get. K times zero, which is still what? 800 e to the power zero. So e to the power 0 is what? 1. So this is the same as 800. So we can say with confidence that the 800 is the population of bacteria at the initial time or at the start of the experiment. This word must be the initial. Okay, so at the start of the experiment, the time is always what? Zero. That one we know for sure. So you can't just rise up and conclude that, oh, this is the rate of the experiment. No. Okay. So don't forget that at the initial time is what? Time t is zero. Given that the population is 20,000 2 days after the start of the experiment. Calculate the value of k. So here p is 20,000, and they say 2 days, so the time is what, 2. All right, so this one can be written as 2k. We should find the value of k. So you can divide both sides by 800. Okay, so 0 0 cancel. So you have um 200 over 8, which is the same as 25. So this 25 is equal to e to the power 2k. So what do you do at this stage? You take length of both sides from what we learned. So this will give you, so I divide both sides by 2 and I get this. Okay, so k is equal to half length 25. And you know that this one can be written like this, which is the same as square root of 25. Square root of 25 is what? So k is equal to length 5. Okay. Calculate the population 3 days after the start of the experiment. 3 days. So right now you're looking for p. When the time is what? 3. Don't forget that you now know the value of k. So you have 3 times k. K is what? Length 5. Okay. So this is the same as, let's take our calculator and calculate and see. 800 e to the power 3 ln 5. Okay, I'm getting 100,000. 100,000. So I'm getting p to be 100,000. Let me cross check to be sure. Yeah, it's 100,000. Simple, right? Okay, there's another one here. The population of a bacterium 2 hours after measurements. So the population is B, is given by this. Okay, find B when t is 0. So that's the initial time. So I just put 0 here, e to the power 0 over 4. And this is the same as 1000 e to the power 0. And this will give me 1000. You know, e to the power 0 is 1. Okay. Now find the time taken for b to double in size. So if b doubles, multiply both sides by 2. If b doubles, b becomes 2000. Okay. So when b is 2000, I just put it in the modeled formula. They say we should find time. So the 3 zeros will cancel, the 3 zeros will cancel. So right now I have 2 is equal to e to the power t over 4. What can you do here? You can find length of both sides. So that's why we learned exponential equations. Everything is connected. There's nothing that's useless. So this is the same as t over 4. So if I make t the subject, I multiply both sides by 4. I'm getting this. Find the time taken. So let me solve this one. You know this one can be written as 2 to the power 4, which is the same as ln 16, right? So ln 16 is what? 2.77. So the time taken, is it in days? It's in hours. So 2.77 hours, right? Find the value of b when t is 8. Not difficult at all. That's why it's 1 mark. When t is 8. So you're going to have your t is 8. So 8 over 4. So this will give you 8 to the power what? 2. Okay, do cancel. So calculate that one to and see. 7,389. 389 point what? Let's go and check. Point 056. But don't forget that if they don't tell you, you are supposed to correct your answer to three significant figures. Okay. So 1, 2, 3. You can see the number here is greater than 5. So if that's the case, you're going to get 7,390. Hmm. So that is the answer. You know, your bacteria cannot be. It's a fixed number. Okay, it's a population. It can't be in your final answer cannot be a decimal. So you correct it. At least even if you correct to the nearest whole number, if you write, I'm sure that if you write something like this, they'll even give it to you. But don't leave your answer as a decimal. All right. Okay, I can see another one here. Now, the number of bacteria being a certain bacteria, the number b of a certain type of bacteria at a time t days can be described by this. Find the value of b when t is 0. Oh, this one is very simple. So if I 2 times 0 is 0. Still 2 times negative 2 times 0 is still 0. So this is the same as 200 plus 800, and you should get 1,000. Okay, 1,000. Okay, so there's another question here. This is 2020 October, November. Okay, now they said that B is a bacteria in the sample, the number. Okay, P and Q are constant. C is a time in weeks. Initially, there are 500 bacteria. So initially, that's when the time is 0. How many bacteria do you have? B is 500. Which increases? So there's another one which increases after 1 week. So when the time is 1 week, don't forget that T is in weeks, right? T is in weeks, they told you. We have our bacteria to be 600. Okay, so when you can get a simultaneous equation by just putting your values into the modeled formula. P is what? You don't know P? Do you know the value of Q? This is 2 times T. That's 2 times 0, which is still 0. So you are going to get 500 is equal to P plus Q. What about this? 600 is equal to P plus Q e to the power 2t. That's 2 times 1, which is 2. Okay, so this is equation 1, this is equation 2. We can solve them simultaneously. Let's say equation 2 minus equation 1. 600 minus 500 is 100. P minus P is 0. Then we have QE to the power 2 minus Q. They have Q in common, so you can factor Q. So at this stage, I'm trying to make Q the subject. I'm going to divide both sides by e to the power 2 minus 1. So find the value of Q for me. Let's take the calculator and see. I'm getting 15.6 or 0.7. 0.7. Okay. Oh, so if that's the case, we can easily find the value of what? P. Because from equation 1, 500 is equal to P plus Q. Your Q is 15.7. So if I make P the subject, let's see. 500 minus 15.7. 484.3. So that is my answer. All right, I think we are not done. Okay, find the number of bacteria present after 2 weeks. Don't forget that right now we know the value of P and Q. So can I say that B is equal to P is what? 484.3. And what is Q? Q is 15.7 e to the power 2t. Okay, so I have this. I should find the number of bacteria after 2 weeks. So when t is 2, that's what they are requesting for. So 2 times 2 is what? 4. So find the value of this for me. Let's see. 484.3 plus 15.7 e to the power 4. I'm getting 134.49. 134.49. Okay, so now when I correct this one to its number of bacteria, so let's correct to 3 significant figures. So this one will be 1340. Okay, don't leave your answer as a decimal. Find the first week in which the number of bacteria is greater than 1 million. I like to bring the comma sign so I don't miss any of my values. Okay, don't forget that you know the value of P and Q. So they are just telling you to solve this. Have you seen? Yes. So this is why you learned exponential equation so that you can apply it here. So this 1 million, I made this one come here minus 484.3 is equal to 15.7. Okay. So let me divide both sides to by 15.7. So now let's do this calculation and see. 1 million 63663 63663 point what? 0.42. 63663.42. All right, is equal to e to the power 2t. So what do you think you can do here? You can find lane of both sides. So I'm getting 2t to be lane of this. So if I divide both sides by 2, I'll get what? Lane 63663.42 over 2. So I'm getting 5.53. 5.53. So this is almost it's week. So this will be almost 6 weeks. Okay. So in the 6th week. All right. So I think we have tried today, and we will end here today. Don't forget to like and subscribe. Don't forget to tell your friends about this video. See you in the next one. Bye.